am going to demonstrate what happens when the drive trips out on an encoder signal related issue. So this is the PGX3 card here. I am going to, for simplification, just remove one of the terminals inputs, the A+ input, to demonstrate the results of when we have an issue with encoder signal. So I'm going to give the drive a run command. I'm going to pull this wire off, and there is a DEV fault. Now this DEV fault will be found in the fault trace, the U2s, as well as the fault history, the U3s. I will now reset the fault, and now the drive is locked into a PGO-1-H, indicating that the drive now has not seen encoder signal as it should. If you see this scenario where the drive initially trips on a DEV, you clear the fault with the reset, and then the drive goes into a PGO fault, you have lost a signal connection between the drive and the encoder. I have now reconnected the A+ input from the encoder, and the PGO fault has gone away. Now the next thing I'm going to demonstrate is the DEV fault related to motor torque. So I'm going to give the drive a run command. And I've held on to the flywheel on the motor. And if you notice, the drive is locked into a DEV fault. Now it's important to note that right now I still have the run command active on the drive and the run light is flashing. I'm going to release the run command. That means I've released the run command, but the drive is still locked in the DEV fault. Now the question is, how can I determine what caused the speed deviation fault? So there's several ways to do it. I'm going to go into the home key, and I'm going to go into the menu, and I'm going to look under the monitor mode, and I'm going to look at the standard monitor, and I'm going to look at the trace data. So right now the drive has a DEV fault. The remaining information that's loaded into the trace data, the U2s, will be the frequency reference, the actual output frequency, output current, and notice it's, for this application, this motor is rated at 1.2 amps. The drive has put out 2.79 amps. That should tell one there's a problem right away. Okay. Motor speed, hardly anything, 0.02 hertz. That's because I locked the flywheel. Output voltage, don't care about that. This is the important one, torque reference at fault. It says a minus 180% of motor torque. Now, when you reach what's called a torque limit in the drive will, after 0.2 of a second, trip out on a DEV fault. So what we're going to do, we're going to go into the home, and I'll reset the fault. We're going to go into the menu. We're going to go into the parameters. The torque limits are loaded in the group C parameters, and it's actually the C7s. So I'm going to scroll down. There's the C7 torque limit, as well as the anti-shock is loaded in there. And the reverse torque limit, forward torque limit are both set to 150%. This is the maximum amount of torque that the drive will allow itself to produce. Now, we saw that when the drive tripped on a DEV fault, it was at a minus, which is going to be important, 180%. The minus indicates actually the reverse, or if it was a hoist, the down direction, that's set to 150%. Okay, we're going to go back. Actually, we'll just go home, and we're going to go to the menu. We're going to look at the monitors again, and we're going to look at the trace data, and we're going to cruise down to that torque value. And again, you'll see it's minus 180%. Now, one more issue with being at the torque limit and generating a DEV fault. If the motor and drive have not been auto-tuned, that needs to be confirmed or done first. The drive, if it's not been auto-tuned with the respective motor, does not know what output current relates to what motor torque. So confirm that an auto-tune was done.